Perimeter and area are similar figures. We're going to solve problems involving congruent, similar, and proportional reasoning and scale factor to two similar figures or solids. In the area of two similar polygons, you need to remember from chapter 6 we talked about similar figures, and we said that in a similar figure all the corresponding angles are congruent and the corresponding sides are proportional, meaning they have the same ratio. We also learned that that is true of any linear measure, whether we're talking about the perimeter or a mid-segment or a median or any other linear measure that is part of the similar figures. What we said then was that they have a ratio of side lengths, A to B. Well, in this one we're saying that the ratio of the areas will not be the same. What they will be is that ratio squared, so A squared to B squared. So the side length of polygon 1 to side length of polygon 2 is A to B, then their areas will be in the ratio of A squared to B squared. Let's look at finding some of these. The ratio of red to blue of the perimeters. Since perimeter is a linear measure, they will be the same as the ratio of the side lengths. The side lengths are 8 to 12, which is 2 to 3. So the perimeters is 2 to 3. To find the ratio of the areas, then, I need to take the ratio of 2 to 3 and square both of them, giving me a ratio of 4 to 9. So let's apply this. What we have is installing carpet in a bedroom and a den. We know that the carpet for the bedroom, we're told, is going to cost $225. We're thinking about doing the den also, so we want to figure out how much it would cost. And what we can do, since the two are similar, they're both rectangular rooms, then I can find my ratio of the sides, 14 to 10, which is 7 to 5. And then I can square that to find the ratio of my areas. Now the ratio of the area, since carpet is sold by the square foot, then the cost will have the same ratio as the areas. So let's set up our ratio of our areas of 49 to 25 equal to the cost of the den over the cost of the carpet for the bedroom. And when I work this out, I get X is 441, so the answer is D. So here's one for you to try. Perimeter of triangle ABC is 16 and its area is 64. Perimeter of DEF is 12. If the two are similar, find the ratio of the areas and then find the area. Turns out that it is the ratio of the areas is 16 to 9 and the area is 36 square feet. Now, how do they get that? Well, what they did was they said, okay, I've got this triangle ABC, and it says that the perimeter is 16 feet and the area is 64 square feet, or feet squared. I've got another triangle that is DEF. We know that they're similar. This perimeter is 12 feet, and we're looking for the area. So what we need to do is we need to remember that our perimeters, which is 16 to 12, are in the same ratio as the sides. So I'll reduce that. 4 goes into 16 4 times and into 12 3 times. So this is the side lengths ratio. So the area is A squared to B squared, so that will be 4 squared to 3 squared, which is 16 to 9. That's where the 16 to 9 comes from. Where do they get the 36 square feet? Well, 16 is to 9 as 64 is to what? I solve my proportion, I get 36 square feet. A large rectangular baking pan is 15 inches long and 10 inches wide. A smaller pan is similar to it, and all it gives me is the area. And it wants me to find how wide is that smaller pan. Well, first thing I'm going to do is draw this out, label everything, and take a look at it. Notice that I've got my length and width, so I can get my area of the big pan. And I don't have length and width here, but I do have the area of the small pan. So what I can set up a ratio is the areas. The areas are in the ratio of a squared to b squared, which in this case is 96 to 150. Now I need to reduce that to get that common factor out of the way. It becomes 16 to 25. Remember though, this is a squared to b squared. If I want to know a to b, I'm going to need to square root both of those. So if I square root both sides of this, I get a to b is 4 to 5. Now I can set me up a proportion to find my side length. 4 is to 5 is x is to 10, so x comes out to be 8. Regular polygons. Remember, to be a regular polygon, it has to be equiangular and equilateral. All regular polygons of the same number of sides are similar, as are all circles. The floor of a gazebo is a regular octagon, so we know an octagon has 8 sides. Each side of the floor is 8 feet long, and the area is 309 square feet. I want to build a little model of it. The perimeter of the floor of my model is 24 inches, so I want to know the area of the floor of that model to the nearest tenth of a square inch. Well, first thing I'm going to do is I'm going to set me up a proportion with these perimeters, since I know the perimeter of the small one, and I can find the perimeter of the large one. It's just 8 times 8, which gives me 64 feet, and the 24 inches needs to be turned into 2 feet so that I can reduce this and have a true ratio of 32 to 1. Now I could have turned them both into inches and reduced, and I would have the same ratio. So the ratio is 32 to 1. So if I want to deal with areas now, I've got to square both of those. So I've got the 32 squared over 1 squared is equal to the area of the full model, which is 309 square feet. And on the bottom, that's going to have to be in square feet. Even though it says to the nearest square inch, we'll have to deal with that in just a minute. I work this out. I find out that it is approximately 0.302 square feet. But remember, how many square inches are in a square foot? If there's 12 inches in a foot, then in a square foot, there would have to be 144 square inches. So I can multiply that and see that it's 43.5 square inches. Here's the one for you to try. What you come up with is the square root of 5 over 3. Now, how did we get that? Said the ratio, excuse me, the ratio of the areas is 20 to 36. We need to take out our common factor, which in this case is 4. This gives me 5 over 9. But remember, that's a squared over b squared. So I must square root both of them to get a over b, so I get the square root of 5 over 3. Rectangles 1 and 2 are similar. Perimeter is 66 inches. Rectangles 35 feet long and 20 feet wide. Show the steps that you'd use to find the ratio of the areas and then find the area of the rectangle. Well, if I'm dealing with perimeter, I already know the perimeter of rectangle 1. I'll need to know the perimeter of rectangle 2, and I will need to put that in inches. What I get is 35 plus 35 plus 20 plus 20, and then multiply that by 12 to get 1,320 inches. So 66 is to 1,320, reduces to 1 over 20. To get my ratio of the areas, I must square both of those, so I've got 1 over 400, and then I can set up a proportion in order to find the area of rectangle 1, because I can get rectangle 2 area simply by multiplying 20 times 35.